I want to welcome everyone tonight. Tonight, we're going to be talking about how you take a CS major into AI and machine learning, software engineering type roles. I also want to talk a little bit about compare and contrast of a research role out in the working world versus applied engineering role. And to help us with that conversation, we have Elijah Peake, class of 20, with us tonight. Elijah graduated from Middlebury in 2020 with a CS major. After mid, uh, Elijah's first worked with Moody's Analytics as a rotational software engineer with a focus on machine learning and data engineering. He subsequently joined Google at Vertex AI and Google Cloud for 2 years, where he co-founded the Gen AI evaluation service and was a founding member of a tuning quality research workstream. He's now a software engineer at Google's core ML team with nearly 5 years of experience in the machine learning field. Currently wears many hats and supports several DeepMind and Alphabet efforts, including, but not limited to, Gemini 2.5 pre-training distillation infrastructure, creating a new DeepMind reinforcement learning framework for both research and product, and recently joining both a TPU kernel writing effort to optimize model performance and the AI model project to improve model quality. Welcome, Elijah.
Awesome. For having me. Glad to be here.
So why don't we begin with you telling us a little bit about what your current role at Google is all about?
Sure, yeah. So my current role is honestly a bit all over the place. And I have fun with it because of that. So my current team, the Core ML team at Google, is it sits in between DeepMind and the rest of Alphabet. And the main mission is really to take all of the research work from DeepMind and productionize it and make it more readily available to the rest of Alphabet. So, for example, like DeepMind may come up with a new version of Gemini, and it will still not yet be internally available. And then our team's job would be then to make it available for different product areas like, search, Waymo, YouTube, to be able to use those models and expose them to users. So that's just like one piece of it. Another piece is because I sit in between Alphabet and DeepMind, uh, at least at the moment, all of my efforts are actually focused on supporting DeepMind in some of their research efforts and infrastructure efforts. So getting those off the ground, and then once they're off the ground, porting that work over to the rest of Google. So that's what I'm doing right now with the a lot of my work with distillation, which is taking these extremely large models and making them still extremely large, but a little less extremely large. That's helpful for you could imagine wherever we need smaller models and faster inference times. So I'm helping DeepMind get those models off the ground and then helping afterwards, like the rest of Google, be able to use uh, those features and models. So yeah.
Okay, so I'm just give me a sense of what kind of the time frame might be where you're, I'll say, operationalizing those tools.
Yeah, it varies by project. Everything's very fast paced in the ML world right now, especially at least where I am. We always joke around like you'll have a project for 2 weeks and then it'll get canceled. So it's just like it's very fast where you have to get things done, get them done fast, because if it's not done, then we'll just kill it and try something different. Which I think is very like in the spirit of research. Different from my previous roles where it was a lot longer uh term vision, especially with like external customers. You can't really change your focus super quickly, but since my team's completely internally focused now, it's very, very short term. unless you can like immediately prove impact or if there's an extreme need for something. So, um, yeah, that's why I wear many hats. It's we're kind of like in some ways like ML contractors like throughout Google where we help out on the various projects and yeah.
So basically almost like consultants to the rest of Google.
Yeah,
How,
yeah.
how big is your team?
My team is so we're split up into different areas. So we're split up into we have a sub team focused on performance. So that is like making sure that the models are um, fast enough, efficient enough to run on different hardware. You know, they're super big, so we don't want it to be too expensive to run them. So that's one team. Then there's another team focused on making some of our ML stuff open sourced. So there's like for example, historically like TensorFlow, Keras, um, those, and now recently there's the new framework JAX. So those are all also owned by my team. And then my area specifically, I focus on the models and training. So writing the different training frameworks so that different teams within Google can actually um, like customize their models. Yeah.
Okay. All right. I was going to ask you a little bit later in the conversation, but it kind of came up, this notion of research versus
Hmm.
applied. And so I was wondering if, given you've had experience and had a foot in each of those worlds, just talk to us a little bit about the similarities and differences, if you will, as you execute in those two roles.
Yeah. So I'd say the biggest thing for me from like some of my previous experience, so especially at Moody's, actually, I was a rotational engineer, but towards the end, I was actually just on a research group where we are just coming up with internal research for Moody's. This was before the advent of some of these larger models, so it's a very different playing field. Um, but then I also had more recent experience with Google, working with Vertex AI on their the training quality effort. So this was internal research to um, see how we can come up with like best recipes to for our third party training offerings. So to make things work out of the box and out of the box really well for customers, cloud customers who are using our training service. And in both cases, I felt like with the research world, I was very focused on always the numbers of can we deliver like model improvements? Um, and it could get really stressful because there's a lot more up in the air of like how things will actually go. With like for example, you can spend all your time doing, and I think it's similar with research elsewhere. You can spend all your time trying to improve the model quality. You can have a great hypothesis and everything, uh, but you might not actually see the changes you were hoping for. Or you might even get great results in your research, but then when you try to productionize it, it doesn't perform as well as you hoped, which is an even worse scenario. So to me, it was stressful because with it wasn't so black and white. There's a lot more unknown in terms of like, am I actually delivering value? And that was stressful to me because, you know, in the business world, like it's all about the money, it's all about the numbers. So now with when I focus on like the framework side, the infrastructure side, it's very clear whether or not I'm delivering value. It's okay, yes, you improved the training time by X%, or like you introduced this new framework which was able to, you know, improve model quality by X% across the board. So your customers no longer, it's no longer you have a single project. You now have all the projects that use your service as your project. So you kind of
Mhm.
hedge your performance in a way. Um, so yeah, it comes up with its own challenges too. But I also want to call out that there's like different levels to research, and this is something that I've only kind of recently discovered, um, working with DeepMind, where there's the internal research that I had experience with at Moody's and even at Google with Vertex AI. That's like one level of research. And then there's like the bleeding edge research that I've helped out with DeepMind. And the two are very different, very different, where the the bleeding edge research is like I think also like the closer you get to like novelty and like extremely like important work, the your peers around you will also change. So I have found that working on the deep mind side, it like the people are just so incredibly knowledgeable, the smartest people you'll ever meet, and like having like all of them in the same room, the ideas and the innovations that come up are like so incredible, where I felt like those previous worries that I used to have of delivering impact just kind of go away. Where when you have like this huge team of people all working towards the same goal and they're all like crazy work experience. Before they were PhDs and now they're PhDs too, but now they have like 10,000 like reference like citations and like
Mhm.
hundreds of papers each of them. And like I'm just helping out, but like it's a totally different ball game. And so yeah, I think it's also like so much of it isn't just like research versus not research. It's like where you do research or where you do um like not research, like applied
Applied. Let's
ML.
say applied.
Yeah. So because even at Moody's, like when I was doing the applied stuff, it was also a different ball game than now. Um, and yeah, I'll leave it at that. I'm sure you have more questions. Yeah.
Okay. Um, uh, Frequently, it's you're trading one set of problems for a different set of problems, right?
Yeah.
In terms of the different types of in the roles. If you were to kind of advise a student who was pondering, gee, would I be best suited or better suited towards research versus an applied role? What are some of the things that come to mind that you would mention to them to consider or think about as they make that decision?
Yeah, I think that's honestly a really hard decision because even your own preferences are subject to change. Um, like I started out thinking research was really cool, and then I thought, man, I really never want to do research, and then I thought it was cool again, and like it just keeps going back and forth. Um, so I honestly feel like you kind of have to do some soul searching and but at the end of the day, like if you have really good foundations, then you're a lot more mobile. So a lot of the research, so there's at least in the ML world, there's kind of like there are the two fronts where there's infrastructure and there's like the theory of things.
Mm,
If you are really strong with either one of them, you are both valuable to um, research and applied. So you can
mm,
kind of flip back and forth. However, if you have, um, if you have, at least in my opinion, the infrastructure piece, you are more valuable to both efforts. Because research always needs infrastructure, but the infrastructure side doesn't always need the um, like the theory behind everything. Because you can kind of rely on some other people for that.
mhm,
But if I were to like advise someone to like how to choose between the two, I would just say like the only way to know is to get the experience. If you are just so gung ho on the theory of things, then go get a PhD. But if you don't know, then don't go get a PhD. Because the truth is, you can still move your way towards that space. So I graduated in 2020, I have a lot of friends who are graduated same time as me and are now like finishing up PhDs. And I, unlike them, have like we stayed in the same field, but they're in the PhDs the whole time. I, at this point, have gained enough knowledge where if I wanted to transfer into a research role at Google, like I would be competitive for that position. So, like I could be at the same place as them, you know,
Hmm. Hmm.
but instead now I also have like maybe I'm not as good as I'm definitely not as good as at the theory part as them, but I have a lot of flexibility. So, and it's harder for them to like go the other direction. It's still possible, of course. But yeah, I would say like you just kind of have to feel it out, and the only way to do that is to have a like is just to start working.
Hmm.
Um, but yeah, I really for me PhD is really only if you are so certain if you want to do the theory, because if you don't get a PhD, you can still go that route.
Okay, fair.
Yeah.
So I'm just curious, given what you're doing now, what is it that you enjoy about it?
Yeah, I really like how I'm still learning so much. Like it's really intellectually challenging. I feel like I never stopped learning after I left Middlebury, and that was kind of what I wanted. Um, and I think there's a lot of different areas within computer science. Like I've seen some of my friends where you can just like you'll still be learning, but like not quite as much, but your life will be easier. Like if you're just doing like your classic like API work, there's a lot lower barrier to entry, and it's a lot easier to, keep up with the field. Uh, but I would also warn that the easier it is, the more people there will be, and also the more replaceable you'll be. So I think honestly, especially now, it's so important to specialize within the area of computer science. Um, and you're not going to do that in undergrad, you're going to do that afterwards. Um, but it's like you can kind of be a generalist forever, but I think like your life maybe it'll be easier in your day to day initially, but you'll have a different set of stressors where you're going to be worried about staying relevant versus um, you know, putting in the extra effort to learn constantly, but then always staying relevant.
Hmm. Okay, cool. So let's transition into you've been in the working world, you went to mid, you got a CS major, you're in the working world. Given what you know, what should students who are interested in software engineering roles in the ML or AI space do while they're at mid? There's coursework.
Yeah.
What, in addition to that, should they be thinking about and doing?
So I'd say, honestly, like if I were to go back now, I have a lot more understanding of the ML world. Um, I was at Middlebury a double major in computer science and math. Um, I honestly think the math part is so important if you're going into the ML world. Um, like I know we're talking about beyond coursework, but like I think the coursework is so important for the ML world. Like if you like you kind of need to do to be you can always teach yourself everything always. But if you want to make your life a little easier, if you take classes and the ones I'd highlight are probability theory, um, linear algebra, like all the calculus, um, and like if you can stochastic processes, but that's not necessary. Those are like the ones that I would definitely want to take, which I did at Middlebury, and I still use those today. Um, and then for computer science, we have like all the foundation courses that are required are definitely good enough to give you the tools you need to continue your learning. And I did take the machine learning course offered by Daniel Sharstein. I don't know if that's still a thing, but that was actually super helpful. However, I will note that that course basically just followed Coursera's AI course run by Andrew Ng, which is a free material online. So
Okay.
Yeah, I would highly recommend to anyone who's just graduating to start there. Um, so go through the course, understand all the foundations of machine learning through like Andrewing's like Coursera courses. It's a great place to start. Um, I will say that uh, some things are sometimes I feel like even at like in general at school, like not just Middlebury, but elsewhere, I feel like we sometimes it's our learning is so focused on like spitting back the reasons for doing thing that we do things and spitting back equations. But the truth is there's a lot of machine learning to really understand it deeply, you have to understand the why.
Mhm.
Um, and that's how you can understand the like why different research developments happen. So for example, like even when you think of like something as simple as like matrix multiplication, what actually is that? Like what is matrix multiplication? What is that? Like what conceptually is happening? Like when you think about like yeah, like at the most fundamental level, like we know how to do the equation, we know how to like do the algorithm of multiplying two matrices, but what are you actually doing?
Mhm.
Or like with machine learning, like yeah, I would just always try to understand at the most basic level, what is happening? What are we trying to learn? That's that type of curiosity, that way of thinking when you, and like you'll have one question which leads to the next question, which leads to the next question. Just follow those question paths and you're just going to get such a good foundation. And once you have that foundation, honestly, I would then start reading papers. Um,
Right.
being able to read papers is going to be so important if you want to be in the ML world. Um, it's really intimidating at first, but start with the like understanding what attention is. There are papers on like attention, and there was the really transformative paper with that Google released a long time ago, or like not that long, I guess, like 2017, called "Attention is All You Need." The Transformers architecture paper. Read that. Understand exactly everything that's happening. Don't even just like read the equations as is when they're saying like you multiply the Q, V, and K matrices, like understand what each of those matrices are and why we're multiplying them. If you can like I can tell you now like the interviewing questions that um I know like my friends at OpenAI that they give at OpenAI or they give, at Google, they're just asking about the fundamentals in your interview
Mhm.
questions. They're just going to ask you to, can you implement like a forward pass like of a neural network, a backward pass, and then they're going to ask you, that they might get more complicated asking about like different equations and stuff, and more specifically, like they might dissect like the transformers architecture and say like ask you to describe different things, but it's always goes back to the fundamentals because there's not really um, much else you can test on without actually seeing someone try to work in the wild. Uh, so yeah, if your fundamentals are good, you're pretty solid, I would say. And just be curious. Yeah.
Okay. Being curious, that's a good thing. So you spent a bit of time talking about education, whether that's coursework
Yeah.
at Middlebury or Coursera, reading papers,
Yeah.
being curious. What other action should students be taking that, given your own experience transitioning from mid to work, they should be really doing?
Um,
I'm thinking things like independent projects, obviously getting some internship experiences if they can, things like that. What should they be doing?
yeah. So I think at this point, I would say it's like I've read a lot of resumes. And I feel like everyone at this point has independent projects. Everyone has experience. That if you have those, like that's kind of your baseline. Honestly, independent projects, they don't matter that much. Experience is definitely more important, but it's a good thing if you don't have the experience. Um, but the truth is you're kind of, and this is I've said this before, but it's really challenging. I talked about like going for a PhD versus not. If you don't get a PhD, it's really challenging for your first job to be exactly what you want,
Mhm.
especially in the world of ML. You kind of have to build out your portfolio not with your extracurriculars or stuff you do at Middlebury. You build out your portfolio with your work experience after Middlebury. I think that Middlebury right now, like everywhere at this point, at least where I work at the moment, where like my team and everything, there's like virtually no one from any school going out with a bachelor's and joining. Like that's just
Mhm.
not a thing. Um, like super rare conditions. But the truth is you kind of have to start either like you can go do higher education or you can do what I was saying where you start with maybe it isn't exactly what you're looking for, but every step of the way, every career decision you make can bring you a little closer to your ideal. So that's kind of like what I had, where I started out in the rotational program. And I didn't even want to be a software engineer at the time. I wanted to be a data scientist. And in the rotational program, I could see, oh, I like the ML side of things. I want to stay there. And so I built up my portfolio of ML experience at Moody's. Moody's isn't like doing ML at Moody's is not the same as doing ML at Google
Right.
in terms of quality. But then my experience at Moody's made me eligible for experience at Google. But the first team I joined at Google was, yes, it was ML, but it wasn't like, the most ML savvy team. It was structured data, which is very like classic ML, like regression, classification, forecasting, that type of stuff. Um, so, a little lower barrier to entry. But then that experience, then I did well there. And then I went to found the Gen AI evaluation service with one other person. And they chose us just because of like our performance and experience. And that's just kind of how it goes, where you're it's really hard to just start where you want to end. And honestly, like the thing that I always say is opportunities, honestly, they're pretty rare. Like you'll go a whole year working, and maybe one project or two projects of the year will come up that will take you that one step. Like maybe one or two projects will come up where, okay, if I do this project, I can get good experience to put in my portfolio of things that I've done that will legitimize myself as like in the ML world.
Mhm.
For me, I even just had one come up recently. A good example is I was working, I was just in the office, and one of my friends was telling me about how he's joined this like internal course that we have that they just started for literally like a very small group of engineers to teach them some more very low level TPU like kernel code. And it is like a really big commitment, is like a 10-hour a week addition on top of like regular work. So he was like complaining about it. And I was like, you know what? This sounds like a really good opportunity for learning um, who's running the course. So then like I got from him, this was just like 2 weeks ago. And I was like, okay, I see who's running the course. And I reached out to him. I got added to it. But like stuff like that, you have to be really proactive where these random opportunities will come up. And no one's going to, it's not like Middlebury, you don't have an advisor. Like you
Mhm.
are your own advisor and you have to always be looking out because they will come up and you just have to advocate really hard for yourself and you have to be able to put yourself in very uncomfortable situations and putting yourself in these uncomfortable situations where you know nothing Like you have to be able to be ready to embarrass yourself. That's okay because like you will, by putting yourself in these situations, you're gonna learn so much and you're gonna become like the go-to person on so many things. So yeah, that's like the main advice I would have for that.
Okay. All right, but it's good.
Yeah,
Yeah, so you've said a number of things. I just want to recap real quickly. And that is just to remind everybody this first destination is not last destination.
definitely,
It's just that first step. Uh, the career is a marathon, not a sprint.
definitely,
Uh, and as it evolves, as time passes and you have different experiences, you'll begin to better understand and gravitate towards those things of most interest to you, which may
exactly,
take you in a direction which is different than what you thought. You originally have to
exactly.
be open to it.
And that's why I'd also say like when you're starting out, if you don't do the PhD side, like you want to be as broad as possible, in my opinion, starting out. A rotation program is a great example. Like I don't, once you bin yourself, it's really hard to unbin yourself. And when you're a lower level engineer just starting out, you have so much flexibility. You can move around teams, even if you don't do a rotational program, if you're at the lowest level, like you work for a year or two on your team. If you don't get promoted, even if you do, you can switch to a team that does something totally different. But you're eventually going to have to specialize, and you just want to get as much experience as possible starting out to really see what you're passionate about. Because, like you said, it's a marathon. And if you're not passionate about what you're doing, you're not going to be able to keep up with it. And then, yeah, so that's why I honestly think like starting your career at a startup is not a bad idea. Starting your career in a rotational program is not a bad idea. I think those are great ideas. Um, Even if you go to a big company, that's also a good idea. But I would just say, like, honestly, if you go to a big company, don't just stay at the team that you start at. I would say, like, look at what other offerings there are internally, and after a year or two, like, switch. Like, you should see as much as you can when you're starting out because you're not going to get the opportunity later.
So keep your head up, your ears open, and your eyes open.
Yeah, you're just
What's
trying to
going
be,
on?
yeah, it's similar to like, I guess, like the whole liberal arts idea where you're trying to be super broad. And yeah, like you don't, like you graduate Middlebury, you are extremely broad. Like you have just this general idea of what computer science is, uh, but you don't want to like immediately narrow yourself off at that point. You want it to be like a slow funnel versus just like a random point. Yeah. So I think you'll be a lot happier that way because, like we said, it's, you're not gonna start where you want to end, but you also don't want to hate the journey. Like you want to enjoy it the whole way through. Like it's like we're talking about work like, it's the only thing in life, but like, it's not. Like you want to enjoy your whole life, your work, your time working, your time not working. And I think that like it's just so important to just not be so destination focused. And I know it's really hard because sometimes you're in positions that you don't want to be in to start out, but being super broad, like being a generalist initially is really powerful. And yeah.
Okay. Before I throw it open to questions, the Q&A portion, is there any other general advice you think you'd like to give to students?
Uh, I would say honestly, this is something that I struggle with myself. Um, but this is something my dad has always said to me, where you can be like a little fish in a big pond or a big fish in a little pond. Where if you're a big fish in a little pond, like life is good. Like you're just hanging out and you're not super uncomfortable, like you're very comfortable. But there's still lots of like other challenges that come up later where you're stuck in this little pond and you're a big fish. Uh, versus if you are a little fish in a big pond, there's it's so overwhelming. Like I feel imposter syndrome always. It never goes away. Like And the second you start to not feel that imposter syndrome, the truth is you might be now a big fish in a little pond.
Mhm.
So kind of always being a little uncomfortable, I think is actually a really good thing. And just know that it's normal to feel uncomfortable. Like most people feel super uncomfortable. Most people don't know what's going on. Like even at my team, everyone jokes around like, I don't know what's happening. Like I know my very specific area, I don't know what's happening elsewhere. Like the truth is you want to just what you're trying to achieve not only at Middlebury but outside of Middlebury is you're trying to become someone who's able to easily adapt. You want to have such a good foundation that you can easily learn new concepts. And like that's how it is at Middlebury too. Or you're right now just learning the foundation, but you're going to be really well prepared if you not only stay on top of the coursework, but even outside of class do like I was saying, like that extra ML stuff, or just even like honing your CS skills with just like slamming some leet code problems. That's another big thing. Just getting some really good like algorithmic skills. Like all those foundations will help you adapt to new concepts. And it's just everything builds off of each other. So yeah, just stay uncomfortable and like, yeah, and like stay curious and like just focus on the foundations always. Yeah.
Keep learning.
Yeah. Keep learning. And if you don't want to keep learning, like, yeah, it might be easier initially, but it'll get harder later. Yeah.
Okay. So Elijah, I appreciate you spending the time with us, and we're going to be opening it up to questions. Thanks.
Awesome.